of you who are away during class next week. So in this video I'm going to be talking about displacement versus time. Now in our last lesson we looked at distance versus time, and we noted that distance must always have a positive y value, and that the gradient of a distance versus time graph gives you your speed. So let's look at displacement versus time, which is very similar. But one significant difference is that your distance versus time can have negative y values. Okay. All right. So let's take the same example that we did from our distance versus time example. But first, let's draw our graph. Now remember, all graphs should have a title. So this title, as you can see I've written above, is displacement versus time, because it should always be y versus x. So let's have my y-axis. Okay, here's my y-axis. And I'm going to call that displacement. In meters. Now remember, your origin must be the intersection between your x and your y-axis. So, excuse me, that's not the straightest x-axis, but this one is going to be time in seconds. And this point here is my origin 0, 0. So if we look at our example, okay, we've got an object moving forward 2 meters in 2 seconds. So I'm going to put this as 2, 4, 2, 4, 6, 8, 10, okay, -2 meters, -4 meters, and we can always make our axes bigger if we need. Okay, so the object is going to move forward 2 meters in 2 seconds, so it's moving forward, which means it's in our plus section. Okay, and I'm going to connect the dots. So far it's looking the same as our distance versus time graph. Okay, it's then going to stay still for 2 seconds, so the displacement doesn't change, but we're now up to 4 seconds. Now here's where it's going to start looking different. We're going to move backwards 4 meters. So in displacement, that's going to be -4. Okay, so we're going to end up at -2 on our displacement axis in 6 seconds. So that's going to take us up to our 10 seconds. And this is what your displacement versus time graph is going to look like. All right, so now that we've got that graph, let's have a look at what the gradient will tell us. So that's our displacement versus time graph. If I was to try and look for the gradient, okay, again, it's our rise over our run, which is displacement over time. So it's actually going to give you your velocity. Okay, so we're going to get velocity from our displacement versus time graph. Now because this is going into the negatives, I'm going to do an example. Let's say we want to find the gradient of the line, or what velocity were we traveling from t equals 4 to t equals 10 seconds. All right, so we're going to use that same gradient rule. Okay, y2 take y1 over x2 take x1. Okay, now our y2 is going to be the point at 10, -2. So our y2 value is going to be -2. And taking y1, which is our point at 4, 2. So it's going to be -2 take 2 over our x2 value is 10 take 4. Okay, so we're going to end up with -4 on 6, which is going to give us a velocity of -2/3, or negative 0.67 meters per second. Okay, so that tells us the negative there is telling us we're going backwards. So if we wanted to write this a different way, we could say the velocity equals 0.67 meters per second backwards. Okay, because remember, velocity is a vector quantity, so it must have a size and a direction. Okay, and that's all we need to know about our displacement versus time graphs. So that's the end of this recording. Thanks, boys.